So in this video, we're talking about solving proportion equations and simplifying rational expressions. So first we have some basic fraction operation review to work on. So what you want to remember with adding and subtracting fractions is that you need a common denominator. So in order to do this, what we're going to do is we're going to multiply the fraction on the top and the bottom so that it is still an equal fraction. And we're going to multiply it by whatever number will make the denominators the same. So for example, in this first example, I can multiply the second fraction by 7 and multiply the first fraction by 8. And that'll make the bottom of both of those fractions 56. So 3 times 8 is 24. And 3 times 7 is 21. And so we have 24 plus 21. You add the numerators only. 24 plus 21 would be 45. And the denominator of the fraction stays the same. Now, if you could simplify this, if there was a common factor that you could divide both the top and the bottom by, you would want to do that. But in this case, there is no common factor between 45 and 56. So that is our answer. All right, let me do number 3 now. Since this is a subtraction, you have the same general idea for adding and subtracting. You need the common denominator. Now I could multiply the second fraction by 9 and multiply the first fraction by 12, but then I'll end up having to simplify the fraction later. So it will be easier to multiply the first fraction by 3 and multiply the second fraction by, actually, scratch that, because if I multiply 9 times 3 would be 27, and there's nothing that I can multiply 12 by to make it 27. So I'll actually need to multiply the first fraction by 4, and that'll make the denominator 36. And if I multiply the second fraction by 3, that'll make the denominator 36 as well. So we have 3 times 3 is 9, 4 times 4 is 16, and we are subtracting here. So again, once you get the denominator to be the same, it stays the same for the answer, and then you just do the top. So 16 minus 9 is 7. And again, if you could simplify the fraction, you would want to do that, but in this case we can't, so that is our final answer. All right, now let's move on to multiplying, right? So with multiplying, all you do, multiplying is probably the easiest, you just multiply straight. Top times top, bottom times bottom. So we would do 10 times 8 over 7 times 3. So 10 times 8 is 80, and 7 times 3 is 21. And if there was a common factor between 80 and 21, we could simplify, but there isn't anything, so that is our final answer. Okay, and then the last one is, what about dividing, right? So dividing any number, and this actually works even if there aren't fractions, but taking any number, if you're dividing some number, that's the same thing as multiplying the reciprocal of that number. Now reciprocal is just basically flipping over the fraction. And then now this has become a multiplication problem, so we're going to multiply top times top and bottom times bottom. What you can do is simplify before you actually multiply. So if you see 2 and 4, we can actually simplify this. 2 divided by 2 is 1, 4 divided by 2 is 2. So now we multiply 1 times 7, which would be 7, and 15 times 2, which would be 30. And that can't be simplified further, so that's our final answer. If you didn't simplify first, you could just multiply. 2 times 7 is 14, and then 15 times 4 is 60, and then you would simplify the fraction by dividing by the GCF of 14 and 60, which is 2. So you would still end up with 7 over 30 if you didn't simplify first. So that's the review of fraction operations. So let's move on to another thing that we do with fractions, which is when two fractions are equal to each other, right? So you actually have an equation in this case, one fraction equal to another fraction. If you have that, it's called a proportion, right? And the cross product property says that the cross products of a proportion are actually equal. So what this means is I could do 7 times 12 and that would equal 8 times m. So 7 times 12 equals 8 times m. Well, 7 times 12 is 72, I think. Nope, 84. And 8 times m, of course, would just be 8m. Now, because this is an equation, we can actually solve for m by dividing 8 on both sides. So m equals 84 over 8. And of course, this can be simplified, so we want to simplify by dividing the GCF on top and bottom. 84 divided by, we want to divide by 4, which is 21, and then 8 divided by 4 is 2. So we end up with 21 over 2, and we leave it as an improper fraction. All right, so let's do the next one. Again, you have a proportion, and you could do the cross products. So x times 5 equals 7 times 4. 7 times 4 is 28. And so to solve for x, we just divide 5 on both sides. So we get x is 28 over 5. And 28 over 5 can't be simplified further, so that's our final answer. Okay? So go ahead and pause the video and try number 3 really quickly. Okay? So hopefully you were able to try and see if you could do this question on your own. So let me grab another color here. So with this, this question, we're going to do it the same way as we did before. So we're going to go ahead and do 4 times x equals 3 times 8. And 3 times 8 is 24. And 4 times x is 4x. And then we divide by 4 on both sides. And 24 over 4 is 6. 24 divided by 4 is 6. So we got x equals 6. All right. Let's move on to some more seemingly complex proportions. So we still have one fraction equal to another fraction. It's just that on the numerator of this fraction, we have more than one term. But it doesn't matter. You still, if you have a proportion, right, one fraction equal to another fraction, then you can go ahead and do the cross products, and the cross products will be equal to each other. So we have 4 times b minus 8, and it's very important because there are 2 terms that you put it in parentheses, because this will actually be 4 times b minus 8. So both numbers will get multiplied by 4. And then that equals 5 times b plus 3. So again, like I said, you're going to actually distribute, you multiply 4 times b, and you also multiply 4 times 8. So 4 times 8 is 32. And then same thing with 5 times b is 5b, 5 times 3 is 15. Okay, so now we need to solve for b, right? And we can do that by subtracting 4b on both sides to bring those b's to the right. And then we also want to bring the number, the constant, to the left. So I'm going to subtract 15 on both sides to cancel that. Negative 32 minus 15 is negative 47. And 5b minus 4b is 1b. So we end up with b equals negative 47. Okay, let's try another one. So same thing here. As long as you have one fraction equal to one fraction, then you could do the cross products. So 6 times n would just be 6n. 5 times 2n plus 4 will really be 5 times 2n, which is 10n. And 5 times 4, which is 20. Okay, now I have my n's on the right and the left side, so I'm going to go ahead and bring these to the left side by subtracting 10n. 10n minus 10n will cancel. 6n minus 10n is negative 4n, and I'm going to bring down the 20, and then I divide by negative 4 to get rid of the coefficient, negative 4. So we end up with n equals negative 5. All right, so go ahead and pause the video and try out number 3 on your own. Okay, so another proportion here, same thing. We're going to go ahead and cross products are equal to each other. So 4 times 2x minus 4 would be 8x minus 16. And 5 times 3x plus 8 would be 15x plus 40. And then we subtract 8x on both sides to bring the x's over to the right. And I'm bringing the 8x's over to the right, that way I have a positive value of x, but you could technically bring over the 15x to the other side. And then I'm going to bring over the constant to the left by subtracting it. Negative 16 minus 40 would be negative 56. And 15x minus 8x would be 7x. Divide by 7 on both sides. We end up with negative 8 equals x. Alrighty, let's move on to another type of problem. So another part of the review here is to simplify a rational expression. So a rational expression is just basically a fraction that has polynomial in the numerator and in the denominator. So you're looking at basically a fraction that has variables in it. Now, the way that I want to simplify this, of course we could just go in and do 6 divided by 2, and we could do x squared divided by x to the power of 1, and use the exponent properties to simplify this. But the way that I want to do this is by factoring, because that's what we're going to extend and build on that for the more complex problems that we're going to look at next. So the way that I'm going to simplify this is by factoring, because if I have the same factor on the numerator and denominator, then technically that would cancel, right? Like you see over here, right? 2 divided by 2 is really 1, so that ends up canceling. So I'm going to factor the numerator. 6 would factor into 3 times 2. X squared is 2 copies of x. That's times. And y squared is 2 copies of y. So all of those things are multiplying together. In the denominator, 2 doesn't factor any further, and only 1 copy of x. And then you have 4 copies of y. Okay, so now you can see that we have a 2 on top and bottom. 2 divided by 2 is 1. We have a x divided by x is 1. And we have y divided by y would also be 1. Y divided by y would also be 1. So we cancel out all of those things. So that leaves 3x in the numerator and 2 copies of y in the denominator. So that would be y squared. Okay, so that's the way that we are going to simplify our rational expressions. Factor the numerator, factor the denominator, and then you can cancel out common factors. Okay, so looking at this one, right, this is actually already factored. You have the numerator is this binomial times this binomial times this binomial, and in the denominator you have this one times this one times this one. So using that same idea as before, right, this is a factor because it's all in parentheses. So the factor here is 3x minus 1. So you have that 3x minus 1 factor on top, and you also have that same factor on the bottom. So 3x minus 1 divided by 3x minus 1 would cancel. Same thing with 4x plus 5. Do you see how we have 4x plus 5 both on the top and the bottom? That cancels. Now in the numerator here we have 2x minus 3. And in the denominator we have 2x plus 3. Those aren't the same, so those would not cancel. So our final answer here would be 2x minus 3 over 4x plus 5. No, that one canceled, sorry. The denominator is 2x plus 3. Okay. Now there's a part of this that is very important that we need to talk about, and that's excluded values, okay? Now I didn't do that for the previous problem. We're going to go back and do that in just a second. But excluded values, right, are values that cannot be possible for a certain variable. We don't know what the value of the variable is because this is not an equation, so we don't know what the value of the variable is. But there are certain things that the variable could not be because it would make the denominator 0. And the denominator can't be 0 in math, right? If you take any number, doesn't matter what it is, and you try to divide it by 0, you get an error, right? If I bring up a calculator really quickly and I do 7 divided by 0, I get not a number. This is an error. There will always be an error because you cannot group something into nothing, right? When we're dividing by 2, I want 2 groups, right? How many things are in those groups? Well, you can't make no groups. That's just not possible. So that's the issue. We cannot divide by 0 in math. So the excluded values are any values that would make the denominator 0. And if it makes the denominator 0, then it cannot be that number. So how you find this is it's already factored, and you want to do this from factored form because it's very easy. So we have 4x plus 5, that cannot be 0. 2x plus 3, that cannot be 0. And 3x minus 1, that cannot be 0. Because if any of these are 0, then the whole denominator would be 0, right? So x cannot be either negative 5/4 or negative 3/2 or 1/3. And that is a part of the answer. Anytime that you have a variable in the denominator, you have to state whatever values the variable cannot be because it will make the denominator 0. So let's go back and add that in for the problem that we just did before. And you always want to do that before you cancel out any factors, okay? So notice how I did that with all of them, not with just what we had remaining, okay? You want to make sure that you do that and you have the excluded values before you simplify, all right? So if we go back, we actually have 2 variables here. We have x and we have y. So the excluded values are x cannot be 0, right? Because if it's 0, then 0 times 2 times whatever y is to the 4th power would be 0. And also y cannot be 0. So that is a part of the answer. All right, so let's just do some practice here. Now these are not already factored, so we will have to factor it and then we can cancel out common factors. So let's go ahead and factor the numerator. Here, this would be 3 times x plus 6 over x plus 6. So the entire quantity in the denominator is that x plus 6, right? So let's go ahead and write our excluded values. X cannot be negative 6 because if x is negative 6, then this denominator would be 0, which is not good. Now we can go ahead and cancel out the common factor on the numerator. X plus 6 divided by x plus 6 would cancel, and so we just get 3. Okay, let's try another one. So let's factor the numerator on this one. We can factor out x. That would give me x minus 2. In the denominator, this is a trinomial. So I'm going to multiply to negative 2, adds to negative 1. So that would be negative 2 times 1 and negative 2 plus 1. So this denominator will factor into x minus 2 times x plus 1. And then now let's go ahead and do our excluded values before we cancel anything out. X cannot equal 2 or negative 1. And then we can cancel out the common factor of x minus 2. So that would leave us with x over x plus 1. Okay. Now remember, you can only cancel out factors. You cannot cancel out terms. So this is x in the numerator, and we have x plus 1 in the denominator. You can't just cancel out the x. You can only cancel factors. You can't cancel out terms. All right. So go ahead and pause the video and try to do 3 and 4 on your own. Okay. So hopefully you were able to try that. So on the numerator, we're going to factor out 5, leaving us with n plus 7. And then the denominator, let's go ahead and factor out a negative first. A quick tip for factoring the trinomial, right? You always want to make sure if the front number is negative, I always factor out a negative first. And then now that the coefficient is 1, we're just looking for two numbers multiplies to negative 7 and adds to 6. So that would be 7 times negative 1, 7 plus negative 1. So we end up with 5 times n plus 7 over negative, and then this factors into n plus 7 times n minus 1. So the values of n that could not possibly be would be negative 7 and 1. And then what would cancel would be the n plus 7 on the top and the bottom. So we end up with 5 over negative n minus 1. And now to completely simplify, whatever remains, you have to go ahead and multiply together. So I'm going to multiply the negative 1 back in. So we end up with 5 over negative n plus 1. Or alternatively, you could bring the negative to the entire fraction. So this would be a negative 5 over n minus 1. Those two are equal. Or you could bring the negative now to the numerator. You could have it written as negative 5 over n minus 1. So all three of those are equal. What would not be equal would just be negative n minus 1 in the denominator, because obviously you're not distributing the negative to both terms in that case. All right, for number 4, again, you want to factor top and bottom. So I'm going to go ahead and factor the numerator. This coefficient is 1, so we're multiplying to 4 and adding to 4, which would be just 2 and 2. So this is a plus 2 times a plus 2. So you have 2 copies of a plus 2. You could write it as a plus 2 squared. And the denominator, we do have a coefficient, so we're going to rainbow over. 2 times negative 2 is negative 4, so we need numbers that multiply to negative 4, and we'll add to 3. So that would be 4 times negative 1, 4 plus negative 1. And because there is a coefficient in front, I will split the middle. 2a squared plus 4a minus 1a plus 2a squared plus 4a minus 1a minus 2. And grouping the first two terms, I could factor out 2a. That leaves me with a plus 2. Grouping the last two terms, I could factor out a negative 1, which leave me with a plus 2. And then from both of these terms, I can now factor out the a plus 2, leaving me with 2a minus 1. So that's how the denominator factors. Let's write it over here. And then we can cancel out a plus 2 and a plus 2. So our final result is a plus 2 over 2a minus 1. Before I forget, let's write our excluded values because I didn't do it before I canceled these out. But you could see here, a cannot be negative 2 and a cannot be 1/2. Alrighty.